Hey everyone, I hope you're doing well today. In this video, I'm going to be covering 3 different open-ended questions to help you prepare for the Unit 5 assessment. If you're watching this video, hopefully you've already given the problems a try on your own and you're ready to check your answers and revise them to make sure you learn from any of your mistakes. Let's look at number 1 together. A school band performed on 4 different days, and the band sold tickets and they also sold snacks each day at the concert for a fundraiser. The first table shows the number of tickets sold and the amounts of money collected from the ticket sales. That's right over here, okay? And then the second table shows the number of snacks sold. That's snacks for the second table, and the amount of money collected from the snack sale. So that's this second table over here. So we have our tickets to the left and our snacks to the right. Let's take a look at part A rather. In part A, if it says that each snack costs the same price, what is the price per snack? That's going to be a unit rate or a unit price. Okay. It says justify your answer with some work and some maybe sentences. Okay. So it's talking about snacks here. That's what it says in the question. So we're going to look at this table up here to the right first. Okay. Each snack costs the same. So to figure out the cost of one snack, if we're just looking at day 1 here, we could do something like this and do 53.75 and divide that by 43, right? That'll get us the price of just one of these snacks. You could also do something like this $45 on day 2, right? Looking at day 2, and we could divide that by 36, right? The prices of the snacks aren't changing, so we could do any of these division problems. On day 3, we have 75 divided by the 60 snacks they sold. That's day 3. And day 4, you could do something like 81.25 divided by 65. That would be day 4. Now, if you check all of these should get you the same answer. So you really just have to pick whichever one you'd rather do. For me, I think I'm going to just pick, 60 snacks for $75. To me, that maybe just might be the easiest one to do. But again, they should get you the same answer no matter what. Dividing $75 by 60, that's 75 over 60, right? And if you want to write that using long division, you can do that as well. So we can do 75 divided by 60. 60 fits into 75 once. 1 times 60 is 60. Subtracting, we get 15. Decimal, 0, and then bring a 0 down. 60 times 2 is 120. I don't think we can fit it in again. So that's going to be 120 with a remainder of 30. Oh man, we're going to add another 0 and bring that down. And 60 goes into 300 5 times. I know 5 times 6 is 30. And we have a remainder of 0. So it looks like here that one snack is going to cost $1.25. So we can say the price, or it's going to cost it. I just write here, it will cost, or it does cost maybe. It costs $1.25 for one snack. Make that a little more clear. It's a 1. Okay, so we did some work to kind of justify this. If you wanted to prove it a second time, you totally could, right? Maybe if you wanted to back it up by doing another long division problem, you could do something like this, 45 divided by 36. And if you did the 45 divided by 36, you should get the same thing, right? 1 times 36 is 36. That's going to be a 9. I'm going to do decimal, 0. So far, so good. 36 fits into that twice. That's going to be 72. And subtracting, we get 18. Add another 0 and bring it down. And you're right. 5 times 36 is exactly 180. So it's also $1.25. So this does check out if you were not too sure if it was going to or not, but the snacks should be the same price no matter which day they're selling them on. Okay. And when it says to justify using words, you can say, I found an equivalent rate. Equivalent, I can spell that a little better. I think I messed it up a little bit. Equivalent rate. Per one snack. So, I mean, that's basically what we did. And I could say something like using long division, I found the unit rate. Okay, so pretty basic. You're just saying 1 or 2 sentences about what you did to get your answer, why it maybe makes sense. It's an equivalent rate, right? If you divide them both by 60, you can, if you want, you could also write it like this, right? You can write something like, okay, it costs $75 for 60 of these snacks. And then you could divide, you can say something like dividing top and bottom both by 60. And then 60 divided by 60 is 1, so that's 1 candy bar. And 75 divided by 60, we already did the long division. That's going to be 125 for 1 candy bar. So you could also do something like this. I know if you've learned it this way or you've been practicing it this way, that's also another way to go about it. But just showing you a couple different ways you could answer this question. Okay, different ways of laying it out, but in the end, it still costs $1.25 per 1 snack. All right, let's take a look at part B. It says, let me just underline, it says write an equation, okay, that can be used to find y, we need a variable y, which is representing the amount of money collected for selling X concert tickets. Okay, so y is going to be money. I'm going to write that over here. X equals the tickets. Let me go ahead and write it all consistent. X equals the number of tickets. And y is going to be the money. Okay, those are the two variables that we have here. So we're going to write an equation, and we're going to justify the equation with why it works, and then with a sentence or two, and then maybe provide some examples of why this might work. Okay, so we need to find a relationship between the money and the tickets. So looking back up at this table, we're not going to be looking at the snack sales. We're going to be looking at the concert tickets instead. And we're supposed to be writing some sort of equation, and that's going to be a linear equation, right? Everything we've been talking about, or in this unit, is talking about linear equations. So there has to be some sort of rate, okay? So let's see. We have the number of tickets. We know we sold 50 tickets for $275 on day 1. On day 2, we sold 47 tickets for $258.58. Day 3, 62 tickets for $341, and day 4, 75 tickets for $412.50. So assuming this is the same as the snack sales, where the snacks all cost the same, the tickets should also cost the same. So we could divide any of these amount of dollars and number of tickets, and we should get a price for a number of tickets here. So we need the unit rate to write an equation. Okay, so I'm going to write that down. We need to find the unit rate, right? You need the unit rate to write a linear equation. So let's go ahead and find that. Now, out of each of these, I think maybe for me, I'll just start with the 275 and 50. There's less decimals here, so looks a little less scary to me. So we know it's going to cost, I'm going to go ahead and write that down. It costs $275 per 50 tickets. I'm just going to make sure I wrote that down correct. $275 for 50 tickets. That's right. So if we write this down, $275, that's for 50 tickets. To find the unit rate, we're going to have to divide this by 50 and divide this by 50. And we can just do a little bit of long division here, right? So we take 275 and divide that by 50. Doesn't fit in, doesn't fit in. I think this is going to go in 5 times. 5 times 5 is 25, so that's 250. We subtract, that's going to be 25. And we can add a decimal 0, bring this down. And 50 times 5, we know is 250 with no remainder. So this just means that, okay, if you made $275 selling 50 tickets, this is $5.5 or $5.50 for 1 ticket. Okay, so how can we, let me just label this actually. This right here is our unit rate. And we need to think about, okay, like how do we write our linear equation? Well, typically we say it's our dependent variable and it's equal to the unit rate multiplied by the independent variable, right? So the dependent variable, what depends on what? I think if you were to sell more of these tickets, you would make more money. So I think the money depends on the tickets you sell. So the money, remember we said money is going to be y. So we can say y, the amount of money you make, is going to be what? $5.50, the unit rate, 5.5. I guess I'll leave off the dollar sign here, 5.5 per each movie ticket, or each ticket. I forget what kind of tickets these are. So per each ticket, that's going to be x. So how do we write 5.5 times x? We just write 5.5x. Okay. So how can we prove this to work? Well, we can go ahead and say, okay, first of all, let me just box and say this is our equation. And it does say maybe provide examples, right? It says provide maybe examples and then use maybe 1 or 2 sentences to describe why this works. But for an example, let's just say we can go back up here. Let's go to a different day. So supposedly, if you sell 47 tickets, you're supposed to make $258.50, right? So let's just do one example to prove that this does work. So this 47 here is going to be the number of tickets, which is going to be X, and the money is going to be this $258.50 should be Y. So when X is 47, then Y should be $258.50. So let's go ahead and check that. I'm going to make X 47. So if we go write this on the side, we said Y is equal to 5.5x. And so Y should equal 5.5 times 47. And let's see if this does work out. So if I take the 5.5 and I multiply that by the 47, that's going to be 35, carry the 3, it's 35, plus 3 is 38. 4 times 5 is 20, carry the 2, 5 times 4 is 20, plus 2 is 22. Let's go ahead and add these together. It's a 5 and an 8 and a 5 and a 2 with 1 decimal point. So let's go ahead and check out here. If we sell 47 tickets, it would be $258.50. If you sell 47 tickets, this is $258.50. So this does work out. There's our example, and we're happy it does work. Okay, and if you plug in any of the other options, you will see that it does also work out. Okay, so it says justify your equation with why it works. Well, the rate is since, I guess we can say something like since the tickets are $5.50 each, multiplying 5.5 by the number of tickets should give the total price, should equal the total amount of money. Either way is fine. So hopefully you get the gist of this, right? If you keep selling tickets at $5.50 a piece, $5.50 a piece, $5.50 a piece, if you would multiply that $5.50 by however many tickets you make, or how many tickets you sell rather, and you'll find out how much money you'll make. Okay, that's the general gist here. This equation is the total money. This is why the total money, it depends on the rate, right? If you sell it at a more expensive price, you also make more money maybe if people keep buying them. But it really, this Y, or the total money, depends on the independent variable and the unit rate. Okay, that's a product. You're multiplying those together. Okay, so that's part B. And that's this first question. Okay, so for this first question, you just had to answer about the snack, figuring out the unit price. And then for the second problem, we were figuring out the unit price or the unit rate for the tickets, and that helped us write a linear equation. Okay, all right. Let's move on down to question 2. So it turns out that you love riding your bike and you ride 287.5 miles over a period of 25 hours. So maybe you're a really good biker, or maybe you did this over, a few days or weeks or something like that. But when it says in this first question for part A, it says how many miles per hour, that's a rate, right? That's actually a unit rate. Did you ride? Okay, and per 1 hour. So the first thing you would probably do here is you'd go ahead and write 287.5 miles, and that's going to be in 25 hours. And when we want to find the miles per hour, mph, we just have to find it for 1 hour, right? So to find it for 1 hour, you would divide this by 25 and divide this top by 25, and that'll help us find out the miles per 1 hour, okay? So I'm going to just do this on the side. Hopefully I'll have enough space for everything else, but 287.5 divided by 25, you can go ahead and say, okay, this is going to go in once to 28. That's going to be 25. Subtract, that'll be 3. Bring down this 7. It's going to go in one more time. That's 25. Subtract, that's going to be 12. Bring up the decimal, bring down this 5. and 25 is going to go into 125 5 times, and 5 times 25 is 125, and we're left with a remainder of 0. Right, so if we take 287.5 and we divide that by the 25 miles that you are, or 25 hours rather, then we're going to get 11.5. So 11.5 miles per 1 hour, right? So you could go ahead and say, as your answer, you can say this is 11.5 mph, or miles per hour. Okay? That's how fast you were going on average if you were biking 287.5 miles over a 25-hour period, going 11.5 miles per hour. All right, let's look at this next one, this next part. It does say that you ride your bike for 92 more miles, continuing to bike at the same rate. Okay, so that means that same rate is this 11.5 miles per hour. The question says, how many hours, it's asking for hours, will it take you to ride these 92 additional miles? Okay, not too bad. So we know the unit rate is 11.5 miles for 1 hour, right? That's the unit rate. And they're saying, what if you bike for 92 miles? Well, 92 miles, we can put that up here. So the question is, how long will it take us to ride that 92 miles? That's the question we're asking here, okay? So we have to figure out, okay, how does 11.5 become 92? And again, that has to be either through multiplication or division. In this case, it's going to be multiplication because we're getting bigger. And once we find out that number, we're going to do the same thing on the bottom, right? So we're going to go ahead and take this 11.5, and you could guess and check if you want to see like how close you can get without going over, and then we can go from there. But I don't know. I'm thinking maybe 8, 9, somewhere around there. It should be an even number. If you want a foolproof way and you don't really want to guess and check, or if that bothers you in some way, then you can just do the long division, right? I'll do it the long way just to make sure you're following along and understanding. But let's say we multiply these both by 10. So it's really going to be 920 divided by 115. And it looks like we just have to multiply anyway. So let's do 115. I'm going to go with 8. I think that seems reasonable. That's going to be a 440. 8 times 1 is 8 plus 4 is 12. Carry the 1. It is 920. So this goes in 8 times exactly. So instead of these question marks, we're going to put 8 hours. All right. So you can say something along here, along the lines of saying it would take 8 more hours. Okay. All right, cool. So let's move on to part C. It says to stay hydrated. To stay hydrated, you must drink some water while you're biking. Okay, we're going to drink some water. Make sure you don't get too thirsty and get dehydrated. And the last 12 ounces of water you drank allowed you to stay hydrated for 42 miles. So when you drank 12 ounces of water, it let you keep biking for 42 miles. The question is, how many miles can you bike per 1 ounce of water so you don't get dehydrated? Okay, so we're going to set up a rate here. It looks like when you drank 12 ounces of water, you were able to bike for 42 miles. So I think the biking probably depends on how much water you drink, right? So we can write maybe a rate here and say that you were able to travel 42 miles on your bike while drinking 12 ounces of water. Remember, OZ is the units for, or the abbreviation for ounces. So the question says, what if you only have 1 ounce of water, or wondering how far can you bike technically with 1 ounce of water? Well, this is just a unit rate, okay? Just like we were doing before. To get from 12 ounces down to 1, you would divide both top and bottom by 12. We just really have to do 42 divided by 12. So let's say 42 divided by 12. That's going to be 3, that's 36. That's going to be a remainder of what, 6? So I know it's 3.5, but maybe I'll just keep going to show you the full work here. Decimal, 0, and 12 goes into 60 5 times. 5 times 12 is 60, with a remainder of 0. So you could travel, it looks like 3.5 miles. Every 3.5 miles, you should consume 1 more ounce of water so you don't get too thirsty. So it says, how many miles can you bike per 1 ounce of water? And your answer is just, well, 3.5 0.5 miles per ounce. When we say per ounce, we really understand that means per 1 ounce, right? You don't have to say the 1, we just assume that. Okie dokie. Let's move on to, is this the last part? No, there's a little bit more. You end up biking 304.5 miles. How much water would you need to drink to stay hydrated? Okay, so if you drank this much and you want to stay hydrated, saying how much water would you need to stay hydrated? Well, you do already know that I'll just write the rate down, that 3.5 miles is how far you can go with 1 ounce. So the question says, okay, if you wanted to bike 304.5 miles, how many ounces of water would you need to drink to stay completely hydrated? Okay, so trying to see how we're getting from 3.5 to 304.5, it's clearly multiplying by something. Then once we find out that number, we can just multiply it by 1 and it'll be our answer already. So we don't have to work too hard for that, okay? So to find out what 3.5 times what equals 304.5, we can just take the 304.5 and divide that by 3.5. That'll give us the number we need, right? Now, we can't have a decimal on the outside, so we're just going to slide them over. And this is really just going to be 35 on the outside and then 3,045. The decimal goes on the end now, okay? 35 going into 3, no. 30, no. 304, yes. 10 times, that's 350. 9 times would still be too much. I'm thinking maybe 8, okay? 8 times 35. Gotta do a lot of little scratch work here. No worries, I'll find some space. That's going to be 40. 8 times 3 is 24, plus 4 is 28, so 280. If we added another 35 to that, I think that's going to be too much. Yeah, I think so. So 280, and you can check it. When you do the subtraction here, you can just check to see if your remainder is less than 35, and it is. So this is just going to be 24. That's less than 35, so that's good. And 245, well, actually 245 is exactly 35 less than this, so this next number has to be 7. So 7 times 35 is 245. Get a remainder of 0. So this means that 3.5 times 87 does get you 304.5. That means on the bottom, 1 times 87 is going to get us that number. So getting rid of those question marks, this is going to be 87 ounces would keep you hydrated to bike 304.5 miles. So you would need, say something along the lines of, you need 87 ounces. I'm just going to use the abbreviation OZ. Okay? Again, this is all assuming we're keeping a constant rate and there are no other variables involved. If you know 1 ounce of water will take you 3.5 miles before you get dehydrated, then at that rate, at that constant rate, then if you wanted to bike 304.5 miles, you would need 87 ounces to do so. Okay, so let's check this out. We have 2 tables, it looks like here. One of them is dealing with the biking. So I'll just go ahead and label this. This table is dealing with biking, specifically the miles and the hours. And this one's talking about just staying hydrated. So let's just take a look at each of these tables. For biking, let's see, for 1 hour, let's say how many miles? I think we said for 1 hour, you could go 11.5 miles. 11.5 miles in 1 hour. That's true, right? 11.5 per 1. So what if you're going to go 10? Well, to go 10, you would just multiply this by 10, multiply this by 10. So this would be 115 miles in 10 hours, okay? To get from 1 to 18, you would just multiply this by 18, and multiplying 11.5 times 18, let's see, I can do that scratch work on the side. 11.5 times 18, that's going to be 0, 4, 8, 12, 1, 9, it's a 5, 1, 1, 0, 7, 2 with 1 decimal. So that's 11.5 times 18 should equal 207. Is that right? Yeah, I think that is correct. So I'll put a 207 in here. And just for the sake of this video, I'm going to erase these little bits because it's going to get a little messy, but if you were trying to show and leave all your work, I think it'd be a good idea to just try to save it on there. To get to 20, I think the best thing to do is just double 10, right? Multiply 10 by 2. So then doubling 115, I can do that one in my head. Doubling 115, that's going to be 230. Hopefully I did that right. So that's just doubling. Okay, I'm going to go ahead and erase these ones now. And finally, to get to 45, I think the easiest thing is just multiplying this by 45, right? We have the unit rate per 1 hour. So 11.5 times 45. Okay, let's go ahead and do that on side. 11.5 times 45. That's going to be 25. That's a 2. That's a 7. That's a 5. 0, 2, 6, 4, 5, 7, 11, 5. I'm getting 517.5. So let me just think if that makes sense or not. Seems pretty reasonable. Should be pretty high. Should be definitely more than 460. Okay, I think I'm pretty confident with that one. 517.5. All right. All right, and there you have this entire table filled in with all the correct values. And you can check it by multiplying the diagonals, or you can check each of the rates. Another way you can do is just say, okay, like 1 times 11.5 is this, 10 times 11.5 is this, 18 times 11.5, 20 times 11.5, or 45 times 11.5. Unit rate can help you find out all of these values as well. Okay, now onto the water. If we take a look at the water, it looks like for 1 ounce, if you recall from before, you can go 3.5 miles, right? So I can just go ahead and write that in. You can travel 3.5 miles, given that you have 1 ounce of water. Now, maybe I'll use a little different strategy here. In the last problem, I used some arrows going across, but remember, this is just multiplied by the unit rate. So if you have 3 ounces, you can also multiply that by the unit rate, okay? So we could do something as simple as just multiplying each of these top numbers, take each of these numbers, and just multiply these by 3.5. That'll also help you find out how many miles we would fill in this table, right? So if we went ahead and did 3.5 times 3, 3.5 times 3, that's going to be 15, carry the 1, that's going to be 10.5, so I'll put that right here. Multiplying this 10 by 3.5, well, I think that one's pretty straightforward. That's just going to be 35. You just slide the decimal over. For 15, for this 15, we have to multiply this by 3.5. So I'll go ahead and take 15 and multiply that by 3.5. That's going to be 25. Carry the 2. That's a 7. That's a 15. Carry the 1. I believe this is 52.5. Let's see if that's reasonable. I think so. That and that and that. I think that seems right to me. Okay, 52.5, I will put that in that box right over here. And the last one's going to be 37. So if we take 37, and let me find some space to do that. 37 times 3.5. Let's do, I don't know where to put it. Here, I'll just scroll down a little bit. Maybe I can just squeeze on the side actually. 37 times 3.5. 7 times 5 is 35. Carry the 3. That's 15 plus 3 is 18. 3 times 7 is 21. Carry the 2. 3 times 3 is 9 plus 2 is 11. I know I'm adding, so I'll not write that. 129.5 is what I'm getting. 129.5. Okay, cool. So yeah, again, if you're not riding your bike for as many hours, you're not going as far, but if you have more time, then you're going to bike a further distance. And if you only need 1 ounce for 3.5 miles, then as you keep needing, if you have more and more ounces of water, you'd assume that you could actually bike further and further because you can stay hydrated while you're doing so. And now let's move on to our third and final question. So for number 3, we see that you can either buy, you have 2 options. You can either buy a case of 24 water bottles at Mr. Lee's grocery store. That's one option. And that's going to cost $3.12. Or you could buy 36 water bottles for $3.96 at Miss Carsdale's grocery store. So you have 2 different options here. Okay. Part A, it just says to find the unit price per one water bottle at Mr. Lee's grocery store. So what are we buying at Mr. Lee's? What kind of packs do they come in? Well, we know it costs at Mr. Lee's grocery store $3.12. That's for 24 water bottles. So to find the unit price, we need to get the price of one of them. And we can divide top and bottom by 24 to do so. Okay, all right, so we have to do a little bit of long division here, but that's not too big of a deal. I'm just going to use that on the side. I'll put 3.12 divided by 24. It's going to be less than $1 because it doesn't fit into 3, but it's more than 10 cents at least, or it's at least 10 cents. It's 24. 31 minus 24, that's 6 plus 1, that's 7. Bring down this 2. And 24 times 3 is 72, right? So that's 72. Remainder is a 0. So we really can say here that this is going to be 13 cents per one water bottle. So that's our unit price. So 0.13, 13 cents per bottle. That'll be our answer for this first part. Not too expensive, especially if you're buying a big case of it, then per one water bottle, it's only 13 cents. Okay. Looking at part B, we need to now find the unit price per one water bottle, but this time we're looking at Miss Carsdale's grocery store. So at Miss Carsdale's grocery store, we can see that it costs $3.96. That is for 36 water bottles. So it costs more, but you also get more bottles, right? And to find the unit price, we are going to try to get 1 on bottom. So we'll divide by, we'll divide by 36 and divide by 36. So really what we're going to have to do here is take 3.96 and divide that by 36. It's less than $1, as we suspected. It's probably pretty normal. And 1 times 36 is 36. That'll be a 3. Bring down the 6. Oh, this goes in perfectly once again. This is 36 and 0. So looks like at Miss Carsdale's grocery store, it's 11 cents per one water bottle. So 0.11 per bottle, per one water bottle. Okay. There's your answer for part B. Moving on to part C, it says how much would it cost to buy 72 water bottles at Mr. Lee's grocery store? Okay. Well, we already know that it costs 13 cents for one water bottle. So the question is okay, if we want to buy 72 water bottles, how does 1 become this 72? Well, it's just times 72. That's the nice thing about the unit rate. So to get how much it would cost, we'd also have to multiply by the same thing, right? Multiply by 72. So doing that, that's just a little bit of multiplication on the side. Take 0.13, multiply that by 72. 3 times 2 is 6, 1 times 2 is 2, 7 times 3 is 21, carry the 2. 7 times 1 is 7, plus 2 is 9. So adding these up, I'm looking at 936 with 2 decimals, so $9.36 is what I believe this should be. I think that's pretty reasonable. Times 10 would be over $7.20. 936, that seems pretty good. Yeah, 936. I'm pretty sure that's correct. So we can say it would cost $9.36 for 72 bottles. I think that's clear enough, right? All right, hopefully you're still with me, and hopefully this makes making sense to you. If it's 13 cents for one water bottle, it should cost $9.36 for 72 of them at this rate. Okay, that's part C. Part D, what if we are buying 72 water bottles at Miss Carsdale's grocery store? Okay, so Miss Carsdale's was a little cheaper, right? Hers was 11 cents per one bottle. So what if she's buying 72? Or what if you're buying 72 from her store, rather? How does 1 become 72? Well, that's just times 72. And how does 11 cents become, what's the price of them if you buy 72 of them? Well, we have to multiply, all right? So we can take 0.11, multiply that by 72. That's going to be 2, that's going to be 2, that's going to be 7, that's going to be 7, 297 with 1 decimal place after the 7. So 0.11 times the 72, that seems pretty reasonable, more than $7.20, $7.92. So go ahead and put $7.92. And how did I write my answer here? $9.36 for 72 water bottles. Did I do this right? This seems right. 936. 7.92. Okay. $7.92 for 72 bottles. Okay. All right, so let's take a look at part E. And in part E, it looks like the question is if you were to buy 360 water bottles, how much cheaper would it be to buy them from one store versus the other store? So we're buying 360 water bottles in total. So I think the quickest way or the most efficient way to do this is to look at the price difference for one bottle, right? So if you're looking at Mr. Lee's grocery store, that's going to be 13 cents. That's for one water bottle, right? And if you're looking at the Carsdale one, Carsdale, and you look at that unit price, that's going to be 11 cents for one water bottle. So what's the difference between the two prices here per one water bottle? Well, per one water bottle, if you take 13 cents, 0.13, and you take away 0.11, there's a difference here of 2 cents per every water bottle, right? If for every one water bottle that you buy from Mr. Lee's store, you're going to pay 2 more cents than you would at Miss Carsdale's. So the question is how much cheaper would it be to buy them at one store versus the other? So if one bottle, you're already going to be 2 cents cheaper shopping at Miss Carsdale's grocery store, you just have to take the 360 and multiply that by the 2 cents, right? If you save 2 cents for one water bottle, you're going to save a lot more when you buy 360 of them. So this is going to be a 0, a 2, carry the 1, that's a 7. Then we have 0, 0, 0. Add these up, that's going to be a 0, 2, 7, 0, and 2 decimal places. That's going to be $7.20. So you will save, and maybe I'll just move this over to the side so there's a little more space. You'll save $7.20. I'll just put a box around that. That's if you were buying 360 water bottles. You could buy them from one grocery store versus the other. Same exact water bottle, same exact size and everything. But if you knew that it was a little cheaper per one water bottle at Miss Carsdale's grocery store, over the course of, if you drink a water bottle a day, you'll end up saving, $7.20 in the course of a year, right? And different stores have different prices, but it's the same thing. Then this kind of adds up if you do this in different parts of your life, where you try to get the better deal in a lot of different ways. All that money adds up a little bit. Okay, let's take a look at part F. If you sold all the 360 water bottles, let me just underline this as I go. If you sold all of these, right, you bought them and then you sold them, and when you sold them for $1.25 each, and you bought them from the cheaper grocery store, what would your profit be? Oh, interesting. So who was cheaper? Which store? Well, it was Miss Carsdale's, right? That was the cheaper one. And at her store, you would buy the water bottles for 11 cents for one water bottle. But let's see here. That's how much you bought it for. And you're going to sell each water bottle for, you're going to turn that around and you're going to sell that maybe like at, somewhere where people need water and they're willing to pay more for it. $1.25 per one water bottle. So the question is how much would you profit if you sold 360 of them? Well, maybe it makes sense for you to see how much you're profiting per one water bottle, right? If you take $1.25 and you take away the 11 cents that you paid for it, then per one water bottle, aren't you going to profit $1.14, right? For every one water bottle, that's how much you're profiting. So this right here, this is the profit for one water bottle, right? You paid 11 cents for it and you sold it for $1.25, you made $1.14, right? I guess technically you made $1.25, but you were kind of in the hole already for buying it at 11 cents. So you have to kind of pay that off before you say what you really made out on top, $1.14, okay? So we know it's $1.14, that's for one water bottle, but you sold 360 of them. So let's see what your profit would be if you sold all 360 of these water bottles at $1.14 a piece. Profit at least, right? Let's see, that's me a 0, that's 24, carry the 2. That's, I lost my spot there, 10, 4, 2, 12, 14, 1, 4, 4, 0. Then we're going to have a 0, 6, and a 3. And I believe we'll have a 0, 6, and a 3. Yeah. And then adding these up, 0, 4, 10, carry the 1, 11, carry the 1, and a 4, and then 2 decimal places. I think that looks right. So this would be $410.40, and this would be the profit. Okay. Another way you could think about this, I think that's the last question, yeah. Another way you can think about this last problem here is if you wanted to do it a little bit differently, you could definitely see like how much it would cost you to buy 360 of these. So if you took the 0.11 and you multiplied that by 360, then you would get the price of how much you spent, right? And then you could also then take the $1.25 you sold them at and multiplied by 360, and that's how much you made. But then you'd have to take how much you made, this is how much you made, and subtract what it cost you, you would still get this $410.40. So believe it or not, people actually make a ton of money off of beverages or drinks. They mark up the prices quite significantly because people will pay for it. But water bottles really are this cheap if you go to supermarkets. They're as low as 10 to 15 cents per water bottle if you buy a big case of it. And if you typically buy it in a vending machine or other places, oftentimes it's $1 or more, sometimes even $2. Maybe you go to a sporting event, it might be $3, $4, $5. They make a significant amount of money off of water. So something pretty interesting. So I just went over 3 multi-step problems, open-ended problems that will mirror what your quiz might look like coming up next week. So just keep in mind, these are great examples of multi-step problems that really assess whether you know what you're doing when it comes to ratios and rates, comparing unit rates and finding equivalent rates, and just kind of understanding in general what you're doing with them. So I wish you the best of luck, and I will see you in the next one.